Welcome back, AP 10.5, further equations using the ideal gas equation. So we're going to use this equation and help derive density and molar mass from it. So reminder from density is mass over volume, but we're talking about gases. So with gases, the units of density is grams per liter. If we rearrange the equation and put capital M as molar mass. Now, I've never been a fan of how AP does this. I usually call molar mass like little mm, okay? But you'll see why on the equation sheet. So if you call big M molar mass, which is grams per mole, remember the new units of molar mass, and as you see the beware from chapter 4, big M should be molarity. You can derive the equation of the ideal gas equation and solve for molar mass. So remember with volume, okay, if I use my density equation, density is mass over volume. What if I cross multiply and I get volume as mass over density? I can substitute mass and density into where it says volume. So as you see right here. So P, mass over density, nRT, okay? Rearrange the variables to solve for molar mass. Well, remember molar mass is grams, so that's mass over moles. So little m over big N. So when you rearrange this equation, you bring the P over here, okay? You bring the T up, and you bring the moles down. Whole bunch of deriving. This is how we used to have to do it before an equation sheet, okay? So the problem is these two equations I'm about ready to show you are not on the equation sheet, but the ideal gas equation is. So either you can learn how to derive it yourself, or the nasty words that you know I don't like to say is memorize. But I like to call this the meow meow formula. Meow meow, molar mass. Cats put dirt, density, R gas constant, T, over their P, aka pressure. Dirt, right there. Density, RT over P. I always remember the meow meow. I try to find tricks, ladies and gentlemen, because I don't like to memorize. I find mnemonic devices, cool little tricks, so that way I can remember it for all time. So let's work these units. If this is M, but like I tell you, I like to call it MM. Molar mass is grams. Oops. I'm going to have grams over moles. So grams over moles. Okay. Density is grams per liter. R, 0.08206, liters.atm, moles.k. Temperature's got to be in K, and pressure's got to be in ATM. Okay? So all of those units will cancel, and I'll have grams over moles. Okay? I can rearrange this equation and solve for density. So let me show you. Molar mass is dRT over P. Well, if I only want density out by itself, it's cross multiply. Multiply each side by pressure. Pressure's gone. Divide each side by RT. Okay? Don't memorize two. Learn one of them and then learn how to rearrange an equation. People, this is called IM1. This is called algebra. Okay? So my molar mass will be grams per mole. Pressure will be ATM. We already know R. T. But what units will my density be in the N? I should have grams per liter. Okay? Short little video because we just need to practice how to use these two equations. So find the molar mass of a gas. So I want molar mass of a gas at 25 degrees Celsius, which means I need to get that into Kelvin. So might as well go ahead and get that done now. So Kelvin is Celsius plus 273.15. So we're going to plug that in. Looks like nothing after the decimal. So I'm going to get 300 Kelvin. And I'm going to put a decimal there because I don't want it to look like we have 3 sig figs. Or I don't want it to look like 1 sig fig. I have my pressures in ATM. That's good. And I have my density, which is grams per liter. So I got little d, not big D, little d. So I have my equation right here, molar mass, and if you want to put capital M, that's okay. Density, dRT over P. So density, 1.95 grams per liter. Since we don't know who the chemical is, I don't need to write it. Write our gas constant with all of its units, liters.atm, moles.k. And my temperature is 300. And then my pressure is 1.5. I want you to check out the units first. ATM, top and bottom cancel. K cancels with the K on this bottom. Liters, top versus this bottom. And look what you have, grams over moles. Grams over moles, okay? So we're going to plug in, and it looks like 3 sig figs. And if we do this right, looks like my answer should get around 32. And we get 32. So with 3 sig figs, my molar mass, 32.0, and then grams per mole. If we had a chemical, then we would put the chemical right after the units. Okay? Let's practice how to use density. Okay? So if I want to calculate density, okay, remember I like to remember my meow meow, dirt over P, okay? The molar mass of the surface of Titan is 28.6 grams per mole. So there's my molar mass. There's my temperature and my pressure. Assuming ideal, calculate density. Well, because I know how to rearrange an equation, I'm going to bring my pressure up, bring my RT down. So I'm going to get density is pressure molar mass over RT. Okay? So my pressure is 1.6 atm. My molar mass, 28.6 grams per mole. And my R. And because we're talking about the surface of Titan and Saturn and moons, there's no chemical to write here. And my temperature, 95 K. Now, when you plug this in, ladies and gentlemen, remember, we're going to hit your equal sign and then divide, because you're divided by two numbers. So 1.6 times 28.6, and then divide 0.08206, and then divide 95. Looks like we're going to use 2 sig figs, so my calculator said 5.9. And check out the units. I'll do this in a different color. ATM is gone. Kelvin is gone. And my moles is gone. And look right there. Grams over liters. Grams over liters. Okay? The complicated part is remembering two equations. Okay? See you on the next one, AP.